Hey everyone, welcome back. Today we are talking about multi-agent systems. This is part 2 of our AI architecture series. In our last session we covered MCP. That is how AI connects to tools and data. Today we go one level up. We talk about how multiple agents work together. We will design one using a real-world example. That example is a customer support system. This is still a no-code session. We are focused purely on architecture and best practices, so anyone can follow along, even with zero technical background. Let's get started. Alright, here is what we are covering today. First, the problem with using just one agent for everything. Then, what a multi-agent system actually is. We will look at the core architecture that includes the orchestrator and the specialist agents. We will cover key design principles. Then we will talk about a full example step by step. That example is a customer support system. We will cover common mistakes to avoid, and finally, how you can start designing your own system. Sounds good? Let us dive in. Let us start with the problem. Imagine one single AI agent handling your entire customer support. It has to understand the question. It has to search your knowledge base. It has to check out the customer account. It has to write a response. It has to know when to escalate to a human. That is a lot of responsibility for one agent. The instructions become huge and confusing. The agents get slower and less reliable. And when something goes wrong, it is hard to know why. This is the same problem one person doing every job in a company would face. It simply does not scale. So this is where multi-agent systems come in. A multi-agent system is simply multiple AI agents working together. Each one has a specific job. Each one has a narrow focus. Instead of one agent trying to do everything, you build a team. One agent classifies the request, another agent looks up information, another agent writes the response. They pass work between each other, just like people on a team would. This makes each agent simpler. It makes the whole system easier to build, test, and improve. Let us use a simple analogy. Think about a real support team at a company. You do not have one person doing every single task. You have a receptionist who takes the call. You have a specialist who checks account details. You have another specialist who solves the actual problem. And you have a manager who steps in for tricky cases. Each person is good at one thing. A multi-agent system works the same way. Instead of people, you have agents. Each agent plays one clear role, and together they handle the full job. Now let us look at the actual architecture. Most multi-agent systems have two main pieces. The first is the orchestrator. Think of it as the manager or the dispatcher. It receives the incoming request. It decides which specialist agent should handle it. The second piece is the specialist agents. They are focused agents that each one do one job well. There is usually a shared layer too. This includes tools, memory, and a knowledge base. All agents can access this shared layer when they need to. So the flow is simple. Request comes in. Orchestrator decides who handles it. Specialist agents does the work. And the results come back to the user. Let us zoom into the orchestrator. This is the most important design piece in the whole system. Its only job is to understand the request and decide where it should go. It does not try to solve the problem itself. It routes the work to the right specialist. Think of it like a call center dispatcher. The dispatcher does not fix your internet. They just make sure the right technician gets the call. A good orchestrator keeps this routing logic simple and clear. That is what it keeps the whole system predictable. Now let us look at the specialist agents. Each specialist agent should do one job and do it well. This is called single responsibility. In our support example, we might have a few of these. A classifier agent that figures out what the issue is about. A knowledge agent that searches documentation for answers. A response agent that writes the final reply to the customer. Each one has a narrow, focused job. This makes each agent easier to build. It makes each agent easier to test, and it makes each agent easier to improve without breaking the others. So here is something easy to overlook. Agents usually need to share things. This includes tools like a database lookup or a search function. This includes memory of what has already happened in this conversation. And this includes a shared knowledge base like documentation or policies. Instead of every agent duplicating its own copy of these things, you build one shared layer. Every agent can access it when needed. This keeps the system consistent. It also keeps it much easier to maintain. Let us connect this back to our last session for a moment. We covered MCP in detail before. MCP is the standard that lets an AI application connect to outside tools, and this is exactly what powers this shared layer we just talked about. Notice the classifier agent does not need an MCP server at all. It only needs the message itself to figure out the category. This is the right-sized context principle from a moment ago in action. The knowledge agent is different. It connects through an MCP server to get a documentation source. That is how it searches billing documentation in our example. The response agent connects through MCP too. It reaches the ticketing or CRM server to pull account history. That is what let it personalize the final reply. So MCP handles how each agent reaches the outside world, and the multi-agent architecture handles who does what and who needs to reach out at all. These two ideas work together closely. Let us talk about our first best practice. Give every agent a single clear responsibility. Do not build one agent that tries to classify, search, and respond to all at once. If an agent's job description takes 5 sentences to explain, it is probably doing too much. Split it into smaller focused agents instead. A narrow agent is easier to test, it is easier to debug, and it is easier to improve later without breaking everything else. The second best practice is clear handoffs. When one agent finishes it works, it needs to pass its output to the next agent clearly. Define exactly what information gets passed along. For example, the classifier agent should pass the category and the original question. It should not pass a vague summary. Clear handoffs prevents information from getting lost between agents. Think of it like a relay race. The baton pass has to be clean. Otherwise, the whole race falls apart. Our third best practice is about context. You need to decide what each agent actually needs to know. Not every agent needs the full conversation history. The classifier agent might only need the current question. The response agent might need the full history and the customer's account details. Giving an agent too much unnecessary context slows it down, and it can confuse its decisions. Giving each agent exactly what it needs. Nothing more, nothing less. Okay, now let us walk through a full example step by step. A customer sends a message asking about a billing issue. Step 1. The request hits the orchestrator. Step 2. The orchestrator sends it to the classifier agent. Step 3. The classifier agent identifies this as a billing question. Step 4. The orchestrator routes it to the knowledge agent. Step 5. The knowledge agent searches billing documentation for relevant answers. That search happens through the MCP connection we covered earlier. Step 6. That information goes to the response agent. Step 7. The response agent writes a clear, helpful reply. Step 8. If the issue is too complex, the orchestrator escalates it to a human agent instead. That is how a well-designed multi-agent system actually works in practice. Here is the full picture in one diagram. The request flows from customer into the orchestrator. The orchestrator routes to the classifier. The classifier hands off to the knowledge agent. The knowledge agent hands off to the response agent. And a human escalation path sits alongside for risky cases. Notice how clean and traceable the flow is. Every agent has one clear job. Every handoff is clearly defined. Let us recap the best practices so far. 1. Give every agent a single clear responsibility. 2. Define clear handoffs between agents. Number 3. Give each agent only the context it actually needs. Number 4. Always keep a shared layer for tools, memory, and knowledge. And 5. Always include a human escalation path for edge cases. These 5 principles apply to almost any multi-agent system you will ever design. Now let us talk about the common mistakes people make. The first mistake is creating too many agents for a simple task. More agents does not always mean a better system. The second mistake is unclear ownership. If 2 agents both think they are responsible for the same thing, you get conflicts. The third mistake is skipping the human fallback. Not every case can be automated. The fourth mistake is overloading a single agent with too many responsibilities. This brings back the exact problem we started with. Keep the design simple, keep the responsibilities clear, and always plan for the edge cases. So, how do you start designing your own multi-agent system? Start by writing down the full task in plain language. Then break the task into distinct steps. Ask yourself which step require different types of expertise. Each distinct step is a candidate for its own agent. Then define what information need to pass between these steps. That becomes your handoff design. Finally, decide what should happen when things go wrong. That becomes your escalation path. You do not need to write any code to do this planning. This is pure architecture thinking, and it is the most valuable step before you build anything. Alright, let us bring it all together. A multi-agent system is a team of focused AI agents working together. An orchestrator routes the work. Specialist agent each handle one clear job. Good design means single responsibility, clear handoffs, and the right context for each agent. And remember, MCP is what let each agent reach its tools in clean standard way. That is how two sessions connect. Always include a human escalation path. Think of it like building a well-run team, not one overworked employee trying to do everything. Thank you so much for watching, and I'll see you in the next session.